Good morning, class. So today I have decided to do a video lecture for y'all so that you can work at your own pace. You can rewind the video if you ever need to go back and hear me explain something over again, or you can fast forward the video to get ahead if you feel like you've already understood what we're talking about. You are going to be following along with the note sheet that I gave you, taking notes as we go and making sure that you have everything that you need written down. So, with that said, let's go ahead and get started. During the video, there will be pauses for you to answer questions, for me to check your comprehension, and for me to check your understanding to make sure that you are following along. So be prepared and pay attention. And again, you can rewind the video if you need to. So, starting off reviewing with our features of a parabola. This is what we took a test on yesterday, just being able to identify vertex, axis of symmetry, and all these features. So the vertex starts either the highest point or the lowest point. And in this graph, it is the lowest point. So what is that vertex? Well, it's at the point -1, -4. There's the vertex. The axis of symmetry, remember, is a vertical line that passes through your vertex. And so it has the equation x equals, and in this case, it is x equals -1. And yes, there is a correlation to -1 also being the x value of your vertex, which makes sense because it passes through your vertex. Your x-intercepts, where do they cross the x-axis? Here and here at -3 and 1. Where does it cross the y-axis? Here at -3. Now, the sign of the leading coefficient. Remember, if it's positive, it opens up. And if it is negative, it opens down. So this graph is opening up, right? It has that U shape, whereas down would be the upside down. And so our sign is going to be positive. Now, is it a minimum or a maximum? That is determined by our vertex. It is our lowest point on our graph, so it will be a minimum. And our minimum value at -4, the y value. Is my function increasing or decreasing? And this is where we look at it from left to right. So on the left side of my graph, I'm going down, 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 down. So that means it is decreasing until it gets to -1. Then from -1, it goes up, 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 up. And so it is increasing. And so again, that was just a review. If you need to pause the video to go back and kind of listen to the review again, you can do so. Other than that, let's continue with what we're doing today. So here's our learning target. We want to be able to identify the vertex, the axis of symmetry, and the direction of our parabola. We are going to use a new form today called Vertex Form. And using Vertex Form, we're also going to be given a graph, and we're going to be able to write the equation of our graph given using the vertex that we're given in the graph. So we're going to save these what do I need to know for later. We'll come back to it towards the end. So like I said, our new form that we are going to be working with today is called Vertex Form. Go ahead and jot that in your notes. And here's what it looks like. F of x is equal to a times x minus h squared plus k. So don't freak out on me yet. don't start raising your hands and asking me a bunch of questions because we are going to break it down. We're going to break down the letters and what they mean, and by the end of the video, you will be able to know and understand and do problems on your own. So that's what we're going to do now. Let's break it down. But before that, we have one more box to fill in. Vertex form is also known as a transformation. Of the parent function f of x equals x squared. So what this means is that from the basic function x squared, and x squared, I'm going to draw a little graph over here. X squared starts at its vertex is at 0, 0, the origin. And so it forms this parabola, this U-shaped parabola, with its vertex here at 0, 0. And what the transformation is going to do is it's either going to bring it up or down, to the left or to the right. And so your function may end up over here with a new vertex somewhere else. And we're going to look at these transformations to see, well, where does my vertex end up at? So let's break down our formula. Here we have it, big bold letters. So starting with A is going to give me, does my graph open up? And if it opens up, that means A is positive. If it opens down, that means A is negative. So that's what A tells us. A is always going to be found up front before the parentheses, positive or negative, and that tells you, does it open up or does it open down? H is a little bit more tricky. H stands for the horizontal shift. Does it move left or right? And I'm going to do this one in a different color. So horizontal shift. Horizontal. Now, the tricky thing about the horizontal shift is for H, you want to make sure you take the opposite. So if it says minus H, you're going to take the opposite of it. So it's really going to be positive. So off to the side here, we're going to do an example. If it says x minus 3 squared, H really is positive 3. You take the opposite of it. And so it's going to tell you if it's moving left or right. So x minus 3 squared moves to the right. So when it's a minus, it moves to the right. And again, let me do that in a different color so you can see it. Minus means it moves to the right. So then a plus must mean that it moves to the left. And so you can write this in your box a little bit neater than I can, but that's the main thing we need to know about H. Taking the opposite, taking the opposite, taking the opposite. K, however, it is our vertical shift. And K, we can leave it alone. So if it is a plus K, it moves up. If it is a minus K, it moves down.